make sure you are trying to think about the situation that's actually happening. So let's read it. To attend the Cambridge Fall Fair, there's an admission fee. So there's a fee just to get into the park and a cost to go on each ride. So a cost per ride. Maybe you buy tickets. You know what I mean? Have you been to a fair before? Okay, so think about it. There's an initial cost. How much is it? I don't know. We're going to figure it out. But if you go on one ride or you go on 10 rides or you go on 100 rides, that initial cost won't change. That's the entrance cost to get into the park. Does that make sense? If you think about yourself going and paying the money, you connect to it, it's going to be easier to remember. And then there's a cost per ride. So the more rides you go on, the more you're going to pay for that part. Okay, so this is what we're talking about. The relationship between the total cost, which they're calling C. We were using E and H last week a lot for earnings and hours, but it's not always E and H. I'm not too worried about whether you use the right letters, but it's not a bad idea to start getting used to those things changing. Okay, the relationship between total cost C and number of rides N is shown on the graph below. What is the admission fee? What do you think? How'd you get that? How did you know that was where it starts? Noah? Okay, good. Anybody want to add to that? Come on, folks. Think about it. It's kind of what we talked about, but does anybody want to add to that? How many other people thought it was $10, already had the admission fee? So, like we said, see, but what I'm saying is, we need to know that when it says, what's the admission fee? That's the start. That's where it starts on the graph. That's where it starts in the equation. Like that's the part of the question. That's where it starts. And the cost per ride, that's the change. How are we going to figure out the cost per ride? Okay, so what can you see any nice points that we could use there? At 2, what does it go up to? Say that again? 4. Oh, and 4, do you mean like this? Like these 2 points? Okay, good. And what is at 2, how much is it? Somebody else. So it's 15. And then at 4, looks like it's 20. So that was an increase of $5. But that was for 2 rides. So the cost per ride is $5, and this is what some people do, is they just leave it as 5 over 2. But we want to actually get the cost per 1 ride. So we do the division, which is $2.50. So 5 divided by 2 equals $2.50 per ride. And I like to write it with the units there because it reminds me that it means something. And I get used to the idea of units in the rate. And then what's the equation? In the equation, we don't write the units. So I'm going to write C, because that's what it had up here. C, total cost. And we're not talking about earnings now. We're talking about cost. Equals, who wants to try it?
10 plus 2.5.
Very nice. So N was the number of rides. And again, that was given to us here, N. So it was nice to use N, but if you used H or something, it's not the end of the world. Okay. And the other way you might have thought, which we were doing more last week, is 2.5 N plus 10. But the order that we write that doesn't matter. These are both correct. This would be wrong if I did it like this. C equals 10N plus 2.5. That's wrong. The N's in the wrong place. The N has to be with the rate. Okay? Think about what this means. It means every time I increase the number of rides, I'm paying $10. That's not what's happening. That's a different relationship, right? Any questions? I really want to make sure that you understand like where the 10 comes from, why it's that way. If you take the time and you really think about it, it's going to make it that much easier to remember all this stuff. All right, let's try another one. Some of the questions today are all a little bit different, but it's always the same idea. Where does it start? What's the rate? Following graph shows a relationship between amount of money in a bank account and time in days. Can somebody generally just describe what's happening in this situation? Look at the graph. Think about what that explanation just said, the amount of money in a bank account and time in days, and explain what's happening. Charlie? It's decreasing. Very good. Ashton, what do you think? Good? Why is it decreasing? So this is a person spending money. They've got money in their bank account and they're spending money and they're not making any more money or they're not putting any more into their bank account. Very good. What can you tell me about this? This one's a multiple choice because the answers are down there. But before we even look at that, what can you tell me about this? Very nice. So there's going to be a minus sign in there somewhere. That's how we make it go down. What else? Anything else? So what I could do is I could look at the four answers, and what could I do? I could go, not this one because it's adding, and not this one because it's adding, right? Because it's got to be subtraction because it's going down. What do you notice about all four of those answers? They all start at 500, and is that where the graph started? It is. So we can't figure it out based on that. But they're all correct. It started at 500. Very good. So we know it's not that. We know it's not that. And let's take a look at these two. This one says it's going down by $100, and this one says it's going down by $10. So if I go up here, and that's number of days. T is number of days. So if I go up here, I'm going to figure out, maybe I'll do it like this. It started at 500. When did it go down to 400? If it's going down by $100 per day, that should be after 1 day. I like this answer. 4 squares, which is how many days? Because I don't know. I gotta look at the scale and figure out exactly how many that is. So know how many is it days total? 4 squares, but how many? 10. Very good. So we don't even need to worry about how many each square is, but I can see that it started at 0 and it went to 10 and it went over 1, 2, 3, 4 squares. Very good. So that was down $100 in 10 days. So what is this person spending? Kaden? $10 per day, so it's D. Does that make sense? Do you see what I mean? How like all these, the questions are all going to be a bit different, but it still always boils down to where does it start and what's the change, right? Okay, on the back of our giant sheet of paper, an electrician charges an initial fee plus an additional cost per hour. Your parents may have had an electrician or some kind of worker come into their house at some point to fix things. Often that's what they do, right? There's like they charge $100 plus $50 per hour or something like that. There's a fee just to show up at the door. And then there's a cost per hour afterwards. Or sometimes they say the first hour is $150 and then that's $50 per hour after that. It's the same idea, actually. Write an equation for this relationship. So how do we write an equation? Where does it start? What's the rate? So who can tell me? I want you to try it yourself. Okay. See if you can write those two down. I remember on Friday when we we're doing this kind of work where it gives you the graph. A lot of people were turning it into a table. So you're taking the numbers from the graph and making a table. That's a great idea. So what you might do, now one thing that I would recommend though that people did on Friday that you don't have to do, if I'm going to make a table, I'm going to have hours here and cost here. And so 1 hour is cost $100 and 2 hours costs $150 and 3 hours costs $200. So I can see that it's going up by 50 and it's going up by ones. So I could track back and calculate it. And that's what some people are doing. But what else could I do? What's another way that I could figure out the start there? Sam, were you going to put your hand up? No. Jamarli? It says on the graph, so what is the start? 50. You can just read it off the graph. Okay? So you don't have to do it this way. It's up to you. But if you like to use the table strategy, that's fine. You make a table, use it to figure out the rate, but you might want to think about doing that just straight from the graph. You don't have to calculate where it starts. You can see where it starts. Does that make sense? Okay. Has anybody figured out the rate? Who's got the rate done? And how did you figure it out? Justin, what'd you do? Did you get it done? Oh, sorry. What do you think you do? Ashton, what do you think? How'd you figure that out? So because this is counting 1, 2, 3, 4, you can see that for 1 hour it goes up $50. For 1 hour it goes up $50. For 1 hour it goes up $50 like that. Nice. Does that make sense? What's another way that you could do it? I could go from 200 to 100, and I can see that that's a change of $100 in 2 hours. Look, it's 4 squares again, but it was from 1 hour to 3 hours, so that's 2 hours. There's different ways that you could think it through. That was $100 for 2 hours is the same as $50 for 1. And then if we write the equation, what's the equation going to look like? Go ahead. This one's easy because you could, even if you got the 50s backwards, you'd still get the right answer, right? But this is the start. And this is the rate or the change. That could be a really useful thing to write down like that. Reminding yourself what goes where. Everybody okay? Okay. The total cost of renting a boat at a beach is made up of a fixed fee and a cost per hour. The table below shows information about the total cost. Graph the data in the table on the grid below. So what I'm going to do is I'm going to see that 2 hours costs $100, and I'm going to put that on the graph. So 2 hours cost $100. 4 hours cost $150. 7 hours was $225. Now you have a ruler, so you could draw a line and you can figure out where it starts with your line, but I can't quite do that. So I'm just going to draw it like this for now. But normally you would draw it all the way to the end, right? Okay. Now just stop for a second and put your pencil down because I want to talk about a couple of things. What does it ask us to do here? Write an equation that relates the total cost of a ride C to the time the boat is rented. So to write the equation, what do we have to do? We got to figure out where it starts and And we got to figure out what the rate is. What's happening in this table, though? This is something new. This goes up by 50, and this goes up by 75. Remember a while ago when these numbers were different, what did we say? It's nonlinear. But this is linear. It is a straight line. What's happening here? Something weird happening.
It's actually $25 an hour.
Yes. But so why are these numbers different? What's going on?
Because on the left side, the numbers are increasing by 2.
Yeah, this one's 2. And this one's 3. This is really, really important. Put your pencil down and look up here and watch. $50 for 2 hours and $75 for 3 hours is the same rate. It's $25 per hour. You with us here, Noah? Right? $25 per hour. So when we talked before about how if these numbers are different, it means it's nonlinear, that's only if these numbers are the same. It was a little bit trickier than that. And now we know more about these linear relations and about rates and that kind of thing. And I hope you can see that. that $50 in 2 hours and $75 in 3 hours is the same. It's all $25 per hour. So I could track that back. If I want to go back 2 hours and it's $25 per hour, I'm going to go back $50, right? And so to go back to 0, I go back 50, and that's going to take me to 50. But what I could also do, which would be the smarter thing, I think, and if you have a ruler, would be to track my line back and see where it starts. It starts at 50. Doesn't that make sense? The line goes through those 3 points, a nice straight line, and I can follow it back and see that it starts at 50. So the total cost is that $50 where it starts plus $25 per hour. It said it wanted T instead of H. And again, that part doesn't really matter, but. Any questions about that? I think that's the last one, right? Any questions?